Okay, so yesterday kita stop dekat formal charge. Okay, and today kita akan continue formal charge. Kita akan habiskan formal charge, and we will see the different cases, the anomalous cases lah. Because itu kalau you guys ingat, kita akan tahu, kita akan bincang pasal formal charge, and also kita akan tengok pasal exception to octet rules. Okay, the few elements yang dia orang tak nak jadi octet. Okay. So let's see formal charge. So formal charge, yesterday I dah terangkan, it is not an actual charge. Okay, it's just a charge that determines dia punya ke-electronegativity. Okay, so this charge, this formal charge yang kita tengok ni is determined. Contohnya kalau carbon, okay, kalau carbon dia suka untuk ada charge apa, okay, is it plus ke, ataupun carbon suka jadi minus ke, or contohnya oxygen is the most popular atoms. Okay, usually kita akan nampak dia in 2 minus. Okay, we will see kenapa dia prefer to be 2 minus. And kalau you guys tengok dalam materials, I also have included a periodic table, but the values are electronegativity. Kalau you guys tengok my camera, so look at the scale of color tu. Hijau is the least electronegative, and merah is the most electronegative. Where kalau you guys tengok untuk yang hijau, okay, hijau dia orang prefer untuk jadi what is it called? Untuk jadi plus, while merah dia prefer untuk jadi minus punya ion. Okay, so formal charge, kita can decide kita punya formula, kita punya Lewis structure is, kalau boleh, make sense tak? Okay, make sense dengan dia orang punya electronegativity value. Okay, semalam kita tengok for this kan. So kita first is kita label, and then kita cari charge satu-satu. Okay, the total charge. So it means that the charge for each of the atoms, okay, untuk carbon the charge is 0, and untuk A is -1, B -1, and this is 0. Okay, so any you punya Lewis structure, okay, you always need to either samakan dengan dia punya ion punya charge, ataupun be as lowest as possible. Okay, so untuk any structure, dia orang kalau boleh nak 0 semua. Okay, so this is so let's look at this. Okay, determine the most plausible Lewis structure. Okay, so this is plausible, this is dia punya synonym. So plausible in chemistry, it is can be defined as possible and stable. Okay, the most possible, kalau in real world, maybe kita akan jumpa the most plausible Lewis structure. Okay, untuk carbon sulfate, okay, so when kita isi, okay, itu kita buat Lewis structure dia, and we found out that carbon can also create triple bonds. Okay, as well as double bond, dia boleh buat triple bond. So now kita nak tengok what is kita boleh buat the possible, all of this possible is called resonance structure. Kenapa dia called resonance structure? Because as well as sulfur A yang ada single bond, but in other time sulfur A also boleh convert these lone pairs jadi triple bond, which is structure 3. Okay, bukannya bermaksud these are 3 different structure, bukan. Okay, it is the same compound, it's just that sometimes dia dalam bentuk ini, sometimes dalam bentuk ini, and sometimes dalam bentuk ini. So this is called resonance structure. Kalau soalan tanya resonance structure, maksudnya dia nak you lukis all the possible one lah. Okay, But amongst all of this resonance structure, kita ada one structure yang paling plausible. Okay, paling stabil untuk exist lah. So, untuk yang paling stabil, okay, we must have the smallest formal charge. Okay, maksudnya small charge tu kalau boleh nak 0 ataupun rendah lah. Kalau formal charge tu dah kira-kira dapat dalam 5 ataupun 6, maksudnya is most likely it is not plausible. Okay, and then this is the one yang important. So tengok on you punya yang periodic table I given to you, okay, the electronegativity of elements. Okay, macam saya cakap tadi, the merah is the most electronegative. Okay, kalau yang merah-merah atas tu, atas kanan tu, so those elements prefer to have negative charge rather than a positive charge. Okay, vice versa dengan yang warna hijau. Hijau contohnya, okay, sodium lah, sodium Na. Okay, dia benci sangat untuk ada minus. Okay, dia lagi prefer untuk ada plus. So ibarat sodium ni orang baik lah. Dia suka sangat nak menderma. Kalau boleh dia nak bagi elektron dia keluar. Dia tak suka mencuri ni. Dia baik, dia bagus. Dia ikut cakap mak ayah dia. So dia tak nak mencuri. Dia tak suka nak jadi Na minus. Dia suka jadi Na plus. So kalau ada sodium, okay, kita calculate the formal charge. Sodium prefer to have formal charge of +1. Okay, so let's see between these three, kita can see straight away which one is the most plausible lah, kan? Which is this, because kita only have two rules. Okay, kalau boleh dia nak kosong semua, which is the smallest formal charge. Okay, untuk carbon and sulfur, kalau you guys tengok carbon and sulfur, dia punya electronegativity value is quite similar. Untuk carbon is 2.55 and sulfur is 2.58. So it's quite similar. Doesn't necessarily seorang nak jadi positif, seorang nak jadi negatif. Okay, so let's see this OCN minus. Okay, remember kalau dia ada minus, maksudnya dia adalah ion, and you punya Lewis structure always kena ada bracket. So bracket dekat luar. Okay, so which one has the smallest formal charge? So obviously structure 1 and structure 2. Sebab structure 3, sorry, structure 2 ada negative 2. So it is less favorable, alright? So and then kita tengok on rules 2, negative charge are placed on the more electronegative atoms. Which one is more electronegative? Nitrogen or oxygen? So I'll give you the values. Okay, kalau you guys boleh refer the values. Untuk nitrogen is 3.04, while oxygen is 3.44. So obviously the negative charge, okay, orang yang most likely untuk mencuri elektron is the oxygen. So dia prefer untuk ada dekat negative charge ni, untuk ada dekat oxygen. So this is the most plausible. Okay, untuk exam most likely dia akan tanya draw all the possible Lewis structure of OCN. Okay, so you pun tak tahu alamak berapa ada banyak. One tips untuk you guys, soalan ni you nak tahu berapa banyak Lewis structure yang you kena lukis, dia akan ada dalam dia punya marks. Okay, so usually kalau lah marks tu ada 3 marks, maksudnya ada 3 lah structure. Okay, so kalau ada 4, maksudnya 4 lah structure dia. Macam tu most likely lah. Okay, so kita dah habis pasal formal charge. Okay, now kita nak tahu kenapa we learn about formal charge. Okay,
Sir,
yeah.
ada orang tadi line dia slow tapi dia nak masuk sebelum approve.
Okay, so I dah masukkan. Dah kan? Right. Okay, so we have 3 exception to octet rules. Oh Allah, siapa yang masuk lambat ni? Okay. Masuk. Okay. So kita ada 3 exception to octet rules. Ish, ada lagi masuk. Okay, jom. Kita belajar. Saya tak pergi masuk. Dah lebih 10 minit dah. So we have 3 exception untuk octet rules ni. Okay, octet rules means that most likely untuk any contohlah macam argon, dia orang lagi suka untuk ada 8 electrons kan keliling dia. But there are few exception yang menyebabkan the atoms dia tak nak ada 8. Okay, we have 3. We have incomplete, which is tak cukup, expanded terlebih, and odd is janggal lah. So is kita ada tak cukup, so tak cukup 8, okay, terlebih, or or odd lah. Odd dalam bahasa Melayu janggal. I'm not sure. Okay. So untuk incomplete octet, okay, the central atom. So untuk exception to octet rules ni, kita only look on the central atom. Central atom only. Central atom. Okay. So any atom yang dekat tengah. Okay. So this is a cheat sheet lah kalau you guys nak remember senang daripada nak buat sesuatu. Kalau lah the central atom is beryllium, boron or aluminium, most likely dia akan form an incomplete octet structure. While kalau dia adalah phosphorus dengan sulfur, most likely dia akan lebih, and central atom nitrogen and chlorine, most likely dia akan dapat odd. Okay. Untuk incomplete, okay, kalau you guys tengok beryllium, boron and aluminium, these are relatively electropositive. Which mean that dia orang kalau boleh dia orang nak dermakan electrons, dia orang tak nak lebih banyak-banyak. And this is a quite small punya atom. Okay, dia orang okay untuk tak cukup. Okay, dia orang ni orang yang bersyukur dengan apa yang ada. So kalau tak cukup pun tak apa. Okay, while phosphorus, okay, phosphorus and sulfur is a very special one because dia orang ada d orbitals yang boleh accept more electrons. So dia orang boleh ada 6 pula, boleh ada 10. Okay, most likely 10 ataupun 12 macam tu. While nitrogen and chlorine, okay, kenapa dia orang ada odd? Sebab if you remember dia punya central atom nitrogen is group 15, right? This group 15 and chlorine is group 17. Okay, dia orang punya electron valence pun dah odd. Okay, dia ni ada 5 valence electron, while group 7 has 7 valence electron. Okay, that's a general idea why. But untuk soalan dia takkan tanyalah kenapa beryllium ni boleh ada. So just know that we have 3 exception: incomplete, expanded and odd. Itu je. Less than 8, more than 8, or odd number lah. Okay, so this is an example of incomplete octet, which is beryllium chloride. Okay, beryllium chloride, you kira-kira dia punya valence electron semua, you akan dapat 16, and so the first you akan letak the most electropositive atom dekat tengah kan, you letak beryllium, then you letak chlorine dekat keliling dia. Okay, untuk you punya lowest structure, yes, you can buat macam ni, chlorine, yes, macam ni. Tapi this one better untuk you guys buat as sebaris as possible lah, untuk letak sini instead of sini. Because untuk 4.2 kita akan tengok some of it are actually bengkok, and actually the molecule is bentuk macam ni. Okay, so untuk senang just buat dalam sebaris je lah, dia nampak cantik. And then you sambungkan, which is now that you dah sambungkan, you use 1, 2, 3, 4, dah tolak 4 electrons, so you dapat 12 electrons. And then you kena completekan octet untuk all the atoms yang dekat luar. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So dah cukup 12, tolak 12. Tapi beryllium tak cukup lagi. Baru ada 4 untuk beryllium. 1, 2, 3, 4. Okay, kalau you guys remember hari tu, kalau dengan oksigen, okay, contoh carbon dengan, contohlah dengan oksigen, okay, oksigen boleh bagi the lone pairs untuk make a new bonds, okay, untuk jadikan dia double bonds, right? But not for chlorine. So dia boleh ubah jadi double bond, right? But chlorine tak boleh. Okay, remember this. Okay, okay, hydrogen and group 17. Okay, any atoms yang dalam group 17, okay, cannot ever make double or triple bond. Okay, untuk hydrogen and group 17, diorang usually akan buat single bond sahaja, never lebih dari single. Okay, okay, the reason is kenapa dia tak boleh nak jadikan double bond, right? Kenapa dia tak nak jadikan double bond is all to do with dia punya formal charge. Okay, kalaulah chlorine dia buat double bond, dia jadikan double bond, dia jadikan this is double bond. So the formal charge, dia punya calculation for formal charge is dia punya valence electron, which is 7 ish, 7, okay, and then minus kurungan dia punya lone pairs. So contohlah sekarang chlorine ni dah jadikan dia double bonds. So lone pairs ada 4, and then plus half of bonding pairs. So you ada 2, 1, 2, 3, 4, so 4. Okay, now is 4 plus 2. Now you get a formal charge of plus 1. Chlorine sangat tak suka plus 1. Kalau you guys tengok, chlorine is very electronegative. Bawah fluorine, dia prefer untuk jadi minus 1. So kalau you guys tengok, this one, kalau dia tak buat double bond, okay, dia punya valence electron is 7, minus dia punya what is it called, the lone pairs. Okay, ada 1, 2, 3, 4, 5, 6. Kita ada 6 minus dengan half of dia punya bonding pairs electron. So we have 2, right? 6 minus dengan half darab 2. 6 minus which is tambahlah. Okay, 6 tambah 7, so 7 minus 7, right? So it is 0. 0 okay, tapi okay, anything 0 okay, as long as tak bertentangan dengan dia punya electronegativity. Kalau dia negatif, dia hanya nak negatif ataupun 0. Kalau dia positif, only 0 and positive. Okay, example now is expanded octet. Okay, expanded octet. Okay, sulfur is a special one. Why it can have expanded octet? Okay. Bila kita buat SF6, terus kita sebenarnya dah boleh tahu that it is expanded octet, because the only way untuk gabungkan semua ni is melalui S, and F ada 6 lah. Right. Okay. So when kita dah isi, sulfur ni terlebih. And why is so? Okay, if you guys tengok, untuk sulfur, kalau you guys susun, you guys akan berhenti sini kan? Okay, this is dia punya valence electron. But actually, okay, in quantum mechanics, once dia dah masuk shell of n equal to 3, okay, any subshell, okay, any subshell yang possible untuk n equal to 3 also ada, cuma kosong, cuma tak ada elektron. Okay, once energy dia cukup untuk ada 3, and dia boleh, and they also actually ada available 3D orbitals. Okay, even though tak ada electrons, it's just this 3D orbital just ada tapi tak ada electrons. Okay, since dia ada kosong, so since dia ada kosong punya orbital yang available, okay, electrons can be filled in those orbital, making it having an expanded vortex. Okay, and now last one is odd number electron. So odd number, as dia punya name, is having an odd number lah. Okay, so the total valence, one way untuk spot odd number electron, bila you dah total pun dah odd, so most likely akan odd lah. You buat macam biasa, sambungkan and then susun dekat luar, and you just will left with one electron. One electron, you have no choice untuk letak dekat central atom. So that's it. Okay, now I akan bincang one soalan from tutorial. Kalau you guys tengok tutorial korang, to chapter 4, soalan number 8, soalan number 8. So soalan nombor 8, dia tanya pasal POCl3. Okay, tanya pasal POCl3. So dia punya soalan, dia tanya, draw the Lewis structure, that all possible Lewis structure for POCl3. Okay, so POCl3, untuk lukis Lewis structure, okay, kita tak tahu actually POCl3 ni macam mana kan. So let's find out dia punya first step, which is valence electron. Okay, cara nak tulis is very senang kalau you guys buat macam ni, so that jalan kerja korang kemas. So phosphorus dia adalah group berapa? Let me know, tolong bagi tahu untuk phosphorus dia adalah group berapa. Group yang ke berapa dalam periodic table? Tolong bagi tahu, saya tak nampak korang. Okay, group 15, and group 15 are having how many valence electrons? Should have 5, right? 5 valence electron. And oxygen are group 16, should have 6 valence electron, and chlorine are group 17, having 7, but kita ada 3 chlorine, so darabkan dengan 3 total kan. So total, so berapakah ini? So 5 tambah 6 tambah 7 adalah 32 electrons. Betul kan saya kira 32 electrons, dapat 32.
Yes, sir.
Okay, now kita tengok phosphorus, oxygen and chlorine. Which one is the most electropositive? Okay, so phosphorus is 2.19, oxygen is 3.44, and chlorine is 3.98. Okay, obviously it is phosphorus kan, the most electropositive. So pakcik phosphorus ni lah yang duduk tengah. So Mr. Phosphorus akan duduk tengah. Okay, and then you just susun je every other atom sekeliling dia. Okay, so we have satu oxygen and 3 chlorine. Doesn't matter you susun macam mana, still the same. Okay, and then we also have kita perlu sambungkan dia kan. So let's sambungkan. Penuhkanlah. So let's sambungkan this. So kita sambung. Okay, when kita sambung, kita dah guna 1, 2, 3, 4, 5, 6, 7, 8. Kita dah guna 8 electrons. So 8 electrons. So we are left with 24 electrons lagi kan? Betul lah. Betul ke? Yes, betul. Very betul. Okay, so we have 24 electrons. Okay, and this 24 electrons, okay, apa kita perlu buat is kita susun dekat all the atoms yang dekat luar. Mana main mouse? Okay, sini. Kita susun lah. So we have 24, kita susun. Okay, kita guna different color lah nak nampak cantik sikit. Color apa? Color ni lah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So okay, usually this would be the Lewis structure, right? You dah guna 24 and the central atom also dah complete out that. Tapi the question asks, draw all of the possible Lewis structure. Maksudnya ada more than one Lewis structure that is possible. Okay, so kalau you guys tengok, what other possible Lewis structure yang dia boleh buat? Okay, one thing, like you guys remember, oxygen boleh buat double bond, right? Oxygen boleh buat double bond. So this color hitam lah. So color hitam. So any of the lone pairs of the oxygen can become dia punya double bond. So this is one structure, and the second structure also boleh like this. Chlorine, 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 like this. Right, so this is also a possible structure. Even though phosphorus, kalau you tengok phosphorus dah lebih kan? Dia ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, tapi if you remember, phosphorus is one of the atom yang boleh buat expanded octet. Alright, so it is possible untuk phosphorus to have an expanded octet. Mana ni? Banyak betul. So we have two. Now we are in a dilemma. So which one is the most plausible? Okay, yang mana satu? Untuk satu ke dua? Doesn't matter. So how kita nak tengok which one is the more plausible Lewis structure is through formal charge. So cara nak buat formal charge, kalau ada atom yang only ada satu je atom, contoh oxygen dengan phosphorus ada satu je. Okay, now the problem is contoh chlorine. Chlorine ada 3. So namakan chlorine tu macam itu. So nak namakan A, B, C. A, B and C. Alright, so let's do the formal charge. Okay, to oxygen, dia punya formal charge, oxygen has 6 valence electron minus dengan dia punya number of bonding pairs, number of lone pairs. So 1, 2, 3, 4, 5, 6, kita ada 6 plus dengan half of bonding pairs. So this one dia ada 2. And we will get 6 tambah 2 ni berapa ni? 6 tolak 6 tambah 1 7 negatif 1. Betul kan? Kalau saya salah beritahu phosphorus. So phosphorus for this one, dia ada, untuk phosphorus ada 5 minus dengan number of lone pairs has 0 lone pairs, so 0 plus dengan half of bonding pair. So dia ada 1, 2, 3, 4, 5, 6, 7, 8. Ada 8. So 5 tolak dengan 8. So 5 tolak 8 should be negative 3. Betul ke? Betul ke? Betul kan? Saya tanya korang sebab saya pun rasa macam cakap dinding je sorang-sorang. Okay, so we have chlorine A, B and C. So let's calculate. Actually the chlorine A, B and C are quite sama lah. So chlorine are 7 tolak dengan the number of lone pairs, dia ada 6 plus half darab dengan 2. So should dapat
Sir,
ya.
yang
Apa?
phosphorus tu salah.
Dia 1.
Ini ke? Oh jap. Oh ya. Thank you. So ini jadi 4 kan? So jadi positif 1, right? Betul kan? Positif 1.
Ya,
Betul.
Alright. So untuk chlorine A, B and C are sama. So tulislah. So saya nak jimat masa, saya malas nak tulis. Okay. So for this, okay, untuk actually the only difference is oxygen and phosphorus, because chlorine pun sama macam atas, chlorine A, B and C actually sama. So kalau ada exam tulis semua, because this might have marks. Okay. Untuk oxygen, so let's calculate the oxygen. Dia ada 6 minus dengan dia punya lone pairs ada 4 plus half darab dia punya bonding pairs. So 1, 2, 3, 4 plus. And then untuk this phosphorus ada 5 minus dengan 0 plus half darab dengan 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so phosphorus has 0, while oxygen 6 minus dengan 4 plus half darab 4. So jadi 6 dan 6 0 juga kan? So this one 0, 0. Okay, this one also 0 and 0. So pandangan korang, which one is the more plausible Lewis structure? A ke B? 1 ke 2? Untuk 1 ke 2?
2.
Yes.
2.
The reason is it is the lowest formal charge, which is semua 0. Okay. Kalau boleh every single molecule dia nak 0. So dia suka untuk jadi 0. And kalau dia tak buat double bond tu, dia ada, even though it is still 0 kan, minus 1 plus 1, tapi dia prefer untuk kosong the total, semua kosong. Kalau boleh semua kosong dia suka. Okay. So everything fine untuk formal charge, because I nak masuk shapes. Now let's masuk shapes. Alright. So kita akan masuk 4.2. Ininya. So 4.2 is molecular shape and polarity. Okay. So we are looking on actual shapes. Okay. Actually bukannya semua dalam semua molekul yang dalam dunia ni, so macam water, actually bentuk dia bengkok. Okay. Bentuk dia, and actually water have a very specific angle between the hydrogen. And kalau you guys tengok my camera, okay, my camera, okay, so this is actual shape of water. Okay, korang minum setiap hari tu, this is the shape lah water, and the orbitals are very close together. It overlap. Okay, it overlaps. But in this what is it called, chapter, kita akan represent this overlap, the bonds. Okay, this is called the bond, the covalent bond, as panjang lah. So kita akan imagine dia sebagai macam bond yang panjang, even though in actual real life dia memang pendek, dia macam bentuk macam ni je. This is a molecule of water. So let's tengok balik. So in this 4.2, you guys akan belajar VSEPR theory. VSEPR is valence shell electron pair repulsion theory, and some question will ask you to explain this theory. Apa benda teori ni? And then from this theory, we get to know that we have actually ada banyak lagi shape. Tapi untuk this syllabus, you guys akan cover this 5 shape je. Okay, 5 shape ni. And then using VSEPR, kita boleh predict and explain dia punya shape, molecule tu, and bond angles dia. Okay, daripada shape dia, bentuk dia, kita boleh tahu dia punya polarity and dipole moment. Okay, polarity tu is basically charge dia lah. Okay, the overall molecule have charges. Okay, ada charge dekat overall molecules. So contoh kalau oxygen, kalau of water, dia punya polar moment is like that lah, which is positif dekat hydrogen and dia tertarik kepada oxygen, the electrons. Okay, what is VSEPR? Okay, VSEPR is everything about electron pairs. Okay, sebab electron pairs yang kita tengok, sebab kita only tengok valence electron kan, sebab any bonding is only based on valence electron, and kita tengok central atom only. Okay, kita always tengok the shape of central atom lah. All yang keliling dia tu most likely kita macam ignore je dulu for now. Okay, so it is valence VSEPR ni cakap kalau boleh everything dia nak as far apart as possible, kalau dia nak jauh untuk minimize repulsion. Okay, because kalau if you remember, electrons are negative charge. Negative charge tak suka duduk negative charge dekat-dekat. Kalau boleh dia nak duduk as far apart as possible. Okay, so this is an example lah. So the more bonding pairs yang ada, okay, nampak tak? Those other ligands, okay, ligands tu dia apa? Dia punya kaki lah. Okay, the other keliling dia, bukan central atom ni, dia mengelak kalau ada yang baru masuk, dia kalau boleh nak duduk jauh as possible. And mathematician already figured out, okay, which is the most stable and probable way untuk duduk jauh as far as possible. Okay, so let's see of strength of repulsion dulu. Okay, so lone pair to lone pair repulsion is the strongest. So daya tolakan between this dengan the other lone pair is the strongest. It's very strong. Okay, sometimes orang buat lone pair dalam bentuk macam hantu ni, macam hantu Casper. So contohnya water. So water bentuk dia macam ni, and the lone pairs orang sometimes akan lukis macam ni. So sometimes dia orang lukis just 2 titik. Sometimes dia orang lukis like this. This is also a way to lukis the lone pairs. Okay, contohnya like that lah. So this two repulsion is the strongest among them all lah. And the second is the repulsion between this and this. And the weakest, okay, paling lembek is this, bonding to bonding pair. So batang-batang ni lah yang paling weak untuk tolak. Okay, so the repulsion determines the orientation of atom in space. Okay, step in tahu the molecular geometry. So we have 3 steps. First, kita buat Lewis structure macam tadi semua tu, and then kita count all the electron pairs and bonding lone pairs, and then kita sign electron pairs as far as possible. Okay, so contohnya beryllium chloride. Okay, beryllium chloride kita buat Lewis structure dia dapat macam ni. Okay, so apa yang actually kita tengok untuk dapat dia punya molecules? Dia cakap bonding pairs and lone pairs. Kita tengok dekat mana tu? Central atom only. Okay, so dekat central atom ada berapa bonding pairs? Dia ada 1 bonding pairs, 2 bonding pairs. Okay, dia ada lone pairs tak? Tak ada lone pairs. So maksudnya dia ada 2. Okay, so bila ada 2 bonding pairs, bentuk inilah yang paling minimize the repulsion. Make sense lah kan? Satu kiri satu kanan is the furthest away. Okay, so kalau you guys tengok my camera, dia ibarat macam sate. Okay, daging dekat tengah, macam tu je lah. So this is the furthest away and there's nothing yang kita susah nak figure out pun, sebab it's just a straight line macam sate. Okay, so nama dia is linear shape. Okay, shape is linear. Okay, make sense, right? Let's see kalau 3 pula. Okay, 3 contoh beryllium trichloride. Alright, so beryllium trichloride, kita only tengok central atom only tengok central atom. They have 3 bonding pairs. So bila 3 bonding pairs, the furthest away nak letak is in trigonal planar. Okay, trigonal planar maksudnya it is a shape of triangle, and all of the points in the triangle are in the same plane. That's why it is called trigonal planar. Okay, betul lah nama dia trigonal planar. And angle dia, kalau you tengok bulatan, you bahagi dengan 3, the angle is 120 lah, 120 degrees. Okay, but now this is the one yang a bit hard untuk tengok. Okay, now kita ada 4. Contohnya gas kentut korang methane. Okay, gas busuk ni, kalau you guys tengok kira-kira dia punya central atom ada 4 bonding pairs. So dia ada 4. So macam mana nak susun 4 with the most to minimize repulsion as much as possible? We have a shape called tetrahedral. Okay, tetra maksudnya 4. Okay, kita ada 4 edges. So ada 4 edges. Hedral ni is a shape lah, shape dia macam tu. So kalau kita tengok, it's like this, my camera. Okay, look at my camera. So this is the shape. Okay, kalau you guys tengok, you nampak macam trigonal planar. Okay, yeah, yes. Tapi you are looking in 2D. Okay, you have to think in 3D, because now it's no longer in trigonal planar. Kalau you guys tengok, nampak tak? Yes, okay, you nampak. Okay, you nampak this 3 macam planar kan? Tapi, okay, tengok bila I pusing jadi apa? Nampak tak? Dia tak dalam the same plane. It's no longer in the same plane. Okay, no longer in the same plane dah. Okay, this is the plane. No longer in the same plane. Dia macam kaki dia terkangkang. Okay, actually kalau you tengok, dia macam tripod. Okay, nampak tak macam tripod? Tripod korang. Tripod. Okay, it's the shape of a tripod. Macam tu lah, tapi ada 4. Okay, so this is tetrahedral. Okay, remember the name. The name you are expected to know the name tetrahedral. So mana window? Right, so it is tetrahedral. Okay, but now instead of having 4, we are having 5 pula. Kita 5. It is called trigonal bipyramidal. Okay, contohnya phosphorus pentachloride. Okay, this, kalau you guys nampak, kenapa dia cakap trigonal bipyramidal? Okay, trigonal maksudnya it is a shape macam pyramidal lah. Okay, it is a pyramid yang berbentuk 3 segi. Okay, kalau you guys nampak tak dia macam bentuk macam piramid. Okay, yang 3 segi. Okay, piramid yang 3 segi. And bi maksudnya dia ada 2. So dia ada satu kat atas, satu lagi dekat bawah. Okay, satu lagi yang dekat bawah. So dia macam 2 piramid yang tertangkup. Okay, satu dekat duduk dekat dia punya buntut dia orang macam kena. Okay, so dia ada 2 piramid. That's why it is named trigonal bipyramidals. Okay, tengok my camera, and it is bentuk like this. So dia ada, actually tengah-tengah tu is perfectly trigonal planar. That's why shape dia, angle dia is 120 degrees. Okay, and dia cuma ada one axis dekat tengah yang ada atoms. Okay, and those atoms are shaped in 90 degrees. Okay, jarak dia. So this is the most minimal proportion kalau ada 5. And don't worry, yes banyak, you only ada sampai 6 je yang kena perlu tahu. 6 is the easiest. Okay? 6 is the easiest because you letak satu bulatan, you draw all of the axis dekat dia. So bayang macam you guys draw axis je. Okay? Macam itu saya ajar korang draw axis kan. Mana dia? Nah, macam tu lah. This is octahedral. Okay. Octahedrals, dia ada all dekat very end and semua angle dekat sini or dekat sini, semua angle dia sama, 90 degrees. Okay. Remember the angles because question may or may not ask the angle. Alright. So I have given you an explanation on dia punya shapes. Kita ada 1, 2, 3, 4 and 5 shapes yang you guys perlu tahu. Okay, tahu nama dia as well as dia punya angles. Alright, so there's a few yang okay, linear ada only one angles which is 180. Trigonal planar pun ada only one angle 180. This one is also 120. Sorry, this one also 120. Okay, tetrahedral also you have to remember the main angle is 109.5 and it is quite specific, it's 109.5. You bagi 109, jawapan dia salah. It's 109.5 and trigonal bipyramidal is a bit special sebab dia ada dua angles. Okay. Angle this one is 120. Untuk this ke this also 120 and same for this to this is 120. But untuk sini is actually an acute angle, so it is 90 degrees. Right? And octahedral is the easiest. Everything is semua acute, so semua 90 degrees. Right. So kalau you guys tengok, you punya gap handout, there's a lot of empty spaces with the pairs. Okay. So kalau you guys tengok, I will show you dulu the all of the pairs. Nanti kalau ada I think I'll make a video, kita akan draw together because what I want you, okay, sekarang jangan isi lagi. Okay, boleh isi semua ni kecuali molecular shape. Molecular shape kosongkan dahulu because nanti I akan buat video, you guys tengok the video untuk draw. Boleh? So kalaulah kita ada dua pairs, so dua pairs doesn't mean bonding saja, dia can be bonding and lone pairs. Okay, doesn't matter. Tapi contohlah kita ada dua, so the only possible is linear. Tak kisahlah satu bonding satu lone pair, mostly linear. So maksudnya the shape is 100 is like this and the angle is 180 and one of the example is carbon dioxide yang you guys hidup yang you guys hembus setiap hari itu. So carbon like this. This is the shape of carbon dioxide. Okay. But now it's getting interesting when we have 3. Okay. Contohlah kita ada 3. Okay. And all of the tiga pairs tu is bonding. Okay. So it has trigonal planar. Very simple. But now what make it interesting is, what if kita ada 3 pairs tapi one of the pairs are lone pairs? Satu pair tu adalah lone pairs. So it is trigonal planar actually awal-awal. So mana my trigonal planar? So let me show you my camera. Okay, my camera. Okay, tengok my camera. This trigonal planar. Okay, it start with trigonal planar. But now one of the bonds are lone pairs. So instead of having bond, they're lone pairs. So actually the shape is V shape ataupun orang panggil band molecule. Okay. Kalau you guys tengok, dia cakap with V shape or band shape. Okay. Because, okay, tolong tulis kat tepi shape of the molecule will only take account of the bonding punya pairs. Okay, apa-apa yang bonding sahaja akan di take account. Kalau ada lone pairs, even though lone pairs, dia akan make another shape. Okay, kita bayangkan macam lone pairs tu tak ada. Okay, macam ni tadi. Ini actually ada lone pairs. Okay, bayangkan ni adalah lone pairs, kita bayangkan dia tak ada. Okay, kita ignorekan dia. Macam tu. So, dia adalah bentuk V shape ataupun bengkok. So, let's see. Allahu Akbar. Molekul jatuh. Tak apa, jatuh lah. So, since kalau you guys remember, lone pair to lone pair repulsion is the strongest, and then lone pair to bonding pair is the second, and bonding pair to bonding pair is the weakest. Okay. Now, instead of having bonding, kalau sini semua bonding kan? Semua bonding. But now we have lone pairs. So, this repulsion, okay, is stronger than bonding and bonding. So, now actually, the band shape, even though it is initially 120, the lone pairs are pushing this bonding pair closer to each other. Sebab dia stronger, dia tak nak. Dia kuat, dia pergi gym, dia tolak diorang ni. Diorang ni suka tidur je. Ini suka exercise, dia tolak diorang ni. Kan the angle will be smaller than 120. Okay. Untuk jawab soalan, you don't have to know the exact number. Okay, except for water lah. Water dengan ammonia nanti kita akan tengok. Untuk anything yang it makes sense, it is lower than 120, you don't need to know the exact number. The acceptable jawapan is you letak this, which is bermaksud is less than 120. Right. What if kita ada 4 pairs? Will make more headache lah. Pening lah, banyak lah pula. Okay, kalau all of the pairs are bonding, we have tetrahedrals. Okay, molekul saya yang jatuh tadi. And the angles are 109.5 degree. Alright, so this one 109.5. Okay, but now one of the bonding pairs kita replace dengan lone pairs. Okay, actually dia tak ada bonding pair pun. Actually it is what is it called? A lone pair. Mana pergi? So here, look at my camera like that. So one of the bonding pair is lone pair now. So kita bayangkan dia macam lone pair tu tak ada, and it's actually like a trigonal planar. Kalau you guys tengok, it's not trigonal planar exactly. Kalau you guys tengok dari atas, nampak macam trigonal planar, right? Tapi it is a trigonal pyramidal. Kenapa? Sebab it is a pyramid. You guys nampak, it is actually a pyramid yang ada 3 segi. So ada 3 segi. So it's not actually, kalau you guys tengok dari sini nampak macam trigonal planar, but it's actually ada angle. Dia terkangkang sikit. Okay. Tapi sekarang kita buang satu je tadi kan. Kita buang satu lone pair, jadi gantikan dia lone pairs. But now kita buang lagi satu. Okay, kita buang lagi satu. So now actually bentuk Allah. Okay, sorry saya terkeluar tadi. Okay, but bila kita dah buang lagi satu, actually dia punya bentuk is same macam tadi. It is V. Bentuk dia V shape. Sama sahaja. Itulah bentuk dia. Right. So the only thing you have to take note is water lah. Water is very common, dia tanya the exact number. Exact. Right. The exact number for water is 104.5, the angle between this. 104.5. And dia actually ada 2 lone pairs. Sini satu dan sini satu. Okay. Okay, next time nanti saya akan buat video untuk cara lukis dia lah. So this one is very rough lukisan, nampak macam tikus punya arnab punya telinga. Okay, now is trigonal pyramidal. Okay, when trigonal pyramidal, kita buang satu dia nampak macam seesaw, kita buang dua nampak macam T-shape, and buang tiga dia nampak macam linear. Okay, kenapa dia buang sini? Because kalau you tengok, kenapa dia buang dekat area yang dekat sini, dekat pinggang dia ni, dekat bentuk yang trigonal planar ni? Because by buang here, you reduce the most repulsion. Why so? Kalau you guys tengok, dekat dia punya pinggang ni has the most repulsion sebab dia dekat dengan this. Nampak tak? Dia ada 3. So kalau you buang satu, you dah reduce 1. Okay, and you buang lagi satu, you dah reduce another 1, and you buang lagi satu, you reduce another 1. So watch my camera. Here where kita akan buang dekat dia punya pinggang ni. So kita akan start buang satu. Dia adalah bentuk seesaw. Okay, macam mana seesaw tu? Because dia orang view it this way. Okay, this is a plane. Kita want tepi kan? Nampak tak macam seesaw? So macam seesaw. Okay, dia naik like that. Okay. But now bila kita buang another one, kita ganti dengan lone pairs, it is bentuk T-shape. Because it looks like a T. And when we buang another one, it is a linear. Okay, it is a linear even though actually here ada lone pair, ada dua lone pair, ada dua lone pair. Tapi always remember kita ignore the lone pairs, right? So let's go on. Kalau octahedral is quite easy. All sides ada atom, and kita buang satu, kita dapat square pyramidal, and another one kita dapat square planar. So tengok my camera again. You can buang anything, anyone dekat sini yang you nak buang, tak kisah. Only thing yang nak kita remember is dekat trigonal bipyramidal. Kita buang dekat pinggang dia. Sini dekat mana pun sama actually, right? Okay, macam ni ke macam ni. So saya buanglah satu. Saya buang satu. Okay, dia adalah bentuk square pyramidal. Apa maksud by square pyramidal is, kalau you guys tengok, it is like a pyramid. It's like a pyramid. Piramid yang tapak dia square, right? Tapak dia square and dia semua macam pyramid. And now when kita buang another one, it will be as the shape of a square planar, sebab semua atas plane yang sama, right? Semua atas plane yang sama. And what do you expect kalau kita buang lagi satu? Jadi bentuk apa? Kalau saya buang lagi satu, bentuk apa? Tolong cakap, saya tak nampak orang. Yes, bentuk T. It's called T shape. And kalau kita buang lagi satu, what do you expect? Bend. Okay. So this is an introduction on the shape. Nanti I akan buat video. Maybe by Friday I akan upload. You guys boleh tengok and complete the gap handout. Okay. Because it is a specific way untuk draw the orbitals. Kita use wedges and dashes untuk convey depan dan belakang. Alright, everything okay ke so far? Everything okay?
Okay.
Tadi saya tak share screen ke? Share ke? Saya share?
Ya.
Share.
Okay, go. Saya ingatkan saya tak share, tengok tak ada. So, today, you guys boleh tengok tutorial tu. Nanti saya akan upload the video, you guys tengok lah. So, now kelas kita dah habis, and jom masuk ke Discord and kita boleh ambil attendance, okay? Masuklah ke Discord anda.